Hi guys. Okay, so we're back here, and what we're going to do is we're going to finish up this last section, and you can see we just ended on the last video where we're looking for the backwards. Okay, so where we were given the proportion underneath the curve, and we had to find the z-score. Okay, that's only when you're finding a z-score. Down here, okay, this is not backwards. We're going to go back, and we're going to use some information here to work through using a z-score. Okay, so in a recent tournament, Rafael Nadal served or averaged 115 miles per hour on his serves. Assume the distribution is normal, right? We have to tell you that, and we give you a standard deviation. Okay, so if I write down those things, I've got a mean of 115 and a standard deviation of 6, and I can assume normal distribution. Okay, what we're doing is we're trying to find what percent. Okay, so again, how do I find the percents? You first find the proportion underneath the curve, and then we can convert it to be bigger than 120 miles per hour. Now, you guys, this is not a z-score, right? This is just data from a particular situation. And we can always change that data into a z-score. And so that's what we're going to do first. Okay, so we're going to take this value of 120 and we're going to standardize it, which means change it to a z-score. And this was on our quiz. We're going to take our value of 120, we're going to subtract our mean of 115, and we're going to divide by our standard deviation, right? And you're going to get obviously 5/6, which as a decimal is 0.83. Okay, and we're looking for what percent exceeds it, so greater than 120 miles per hour. Well, 120 miles per hour corresponds to a z-score of 0.83. Okay, so you draw your curve. This is a positive z-score of 0.83, and you're looking for this proportion right here. Okay, exceeds 120. Well, 120 became a z-score of 0.83, and because it says exceeds, we want this value. Now, we can't use table A to find that value because table A gives us to the left. And so we're going to use table A to find this part, which is to the left. Okay, so if I get my table A and I look for a z-score of 0.83, so I come over here, z-score again along the column over here, 0.8, and then 0.03. If I combine those two numbers, that's a z-score of 0.83. And I come across and I come down and I get a proportion of 0.7967. 0.7967. So 0.7967. Now that's this side. That's not what they asked because they want exceed. Well, if this is a density curve, the area under the curve is 1. So all you have to do to get your answer is to do 1 minus 0.7967 in your calculator. 1 minus 0.7967, and I get a value of 0.203. Okay, and that is the answer as a proportion, but they said what percent. So that equals, you move the decimal 2 places, 20.3%. Okay, and so again, this is like real life stuff, right? Nadal serves all the time in tennis, and they track him at every tournament. He's got an average of 115 miles per hour serve, right? The coach says, look, how often is this guy going to serve over 120 miles per hour? 20% of the time. Okay, and so they know this going in so that they can prepare their player who's going to have to face Nadal, right? They're going to have to get some practices where someone is serving over 120 miles per hour, which is crazy to think about. I don't play tennis, but that seems real fast. Okay, last one down here. It's a between problem, right? So now we want to be between 100 and 110. And so again, we're going to standardize both of those values. It's very simple. To standardize something means to turn it to a z-score. You take your observed value of 100, you subtract your average, you divide by your standard deviation, and you get a value of negative 2.5. You take your other value of 110, you subtract your average, divide by your standard deviation, you get negative 0.83. And these are z-scores. So if I want to find the percent that are between those two, I have to find the percent that are between those two z-scores of negative 2.5 and negative 0.83. I'm looking for that value. Okay? And so we're going to have to go back and use that strategy because table A only gives us to the left. And so my answer is going to be, well, let's go find the area to the left of negative 0.83, which is all of this. Okay? That's not my answer because I want to stop at negative 2.5. And so what I'm going to do is I'm now going to go and find from negative 2.5 that little tail part, and I'm going to subtract it. So I have this whole thing that never ends, it goes to the left forever, and then I'm going to chunk off that little piece, and I'm going to end up with what I'm looking for, which is this value. Okay, and I can use, again, table A. Table A will give me exactly the proportion to the left of negative 0.83. So you come here, you have negative 0.8. You look up at the top, which you can't see, but it's up here. Okay, 0.03. So negative 0.83, and you come all the way down, you come across, and it's 0.2033. 0.2033. And then I need to the left of negative 2.5. Well, there's negative 2.5. Exactly means you go to the 0, 0 column, and you get 0.0062. So this is 0.0062. And so my answer is simply going to be, right, this value, 0.2033 minus 0.0062. And if I type that in, 0.2033 minus 0.0062, I get 0.1971. Since they asked for a percent, right, that is the same as 19.71%. Okay, so Rafael Nadal serves around, averaging 115 mile per hour serve with a standard deviation of 6. How often are his serves between 100 and 110? Okay, and so we do that by switching them both to z-scores, right, to find table A to get our answer. So only 20% of his serves are between 100 and 110. Okay, all right, you guys, with those two lessons combined, we should be good to go. If you're a little bit uncomfortable with that stuff, that's okay. That's what homework's for, right? We're going to have a review day tomorrow on Friday where you'll get a homework assignment. And then after Thanksgiving, you guys will come back and I will post reviews of that work so you can prepare yourself for the quiz that's on Tuesday. All right, take care, guys. Have a great Turkey Day.